Now let's take a look at how halogens add across an alkene. So let's just do what we always do, a generic reaction. Some kind of solvent. A lot of times it's carbon tetrachloride, but it doesn't have to be. Where X could be Cl2, Br2, and sometimes it can be I2, but not always. Sometimes it doesn't work. And here you're going to get an anti-addition of the halogen. So X's will add in an anti-fashion. And that's something you just keep in mind. We're going to see the mechanism here right now. All right, guys, so let's take a look at the mechanism of adding the halogen across a double bond. So here's my generic alkene. And let's use just Cl2 for this one. Now the mechanism is a little bit strange compared to what we've already seen, but I'll try to walk you through it. So now, this mechanism, the pi bond attacks the chlorine. This is going to leave. And at the same time, this lone pair attacks that carbon. Because now we have to form the halonium ion, right? So that lone pair has to attack that carbon in order to form the bond. And that will give us our halonium ion, and in this case it will be chloronium because it's a chlorine. Oops. Plus charge will go on the chlorine. Now, at this point, the other chlorine, or the chloride, will attack and open up that ring. Very similar to how oxymercuration, demercuration went, right? If this had been a mercury acetate, it would have been the same mechanism. Same thing. Halogen comes in from the side opposite. And when that happens, you get the following. And there you go. So that's the mechanism. That's how it occurs. The only thing that's a little strange is this mechanism here, because three different things have to kind of happen at once. Pi bond attacks the chlorine, the other chlorine group leaves, and the original chlorine right here has to close the chloronium ring. And it kind of all happens at once. All right, let's talk a little bit about the stereochemistry behind the chlorination or bromination or iodination of a double bond. We have to be pretty clear on this. So let's make sure. So let's do another example. Let's say we're going to attack this 5-membered ring. And let's just use bromine this time. So now the Br the mechanism will look something like this. The pi bond will attack the bromine. That bromide will leave, and this lone pair will come in and attack that carbon. Just like that. Now this bromine can come in from the top of this molecule, or it can come in underneath the molecule. Because remember, molecules are three-dimensional. There's a top and a bottom. If the bromine comes in from the top, the bromonium ion will go up. If the bromine comes in from the bottom, the bromonium ion will go down, and both will form. You'll get a pair of enantiomers. I personally like to draw mine going down. It's personal preference. They could have just as easily gone up. 50-50. So you can most definitely get the enantiomer of this, and you will get the enantiomer of this. Now the bromide attacks the carbon, giving you, and it'll come in from the top, because remember the nucleophile has to approach from the side opposite the leaving group. This bromide or bromonium ion is behaving as the leaving group. So it's taking the bonded electrons with it, right? So this bromine has to come in from the top side. So this bromine is facing down. The bromide comes in from the top. If it were the enantiomer, it would be the opposite. Let me do this. We keep the colors consistent here. And there you go, plus an enantiomer. And that's how the stereochemistry of the halogen addition or halogenation of the double bond occurs.